Have you ever noticed how kids will just like randomly call out numbers?
Yeah.
Like, look, there are 5 birds or something like that. Or
Mhm.
there are so many windows on that building over there.
Yeah.
Like, what is that all about?
Right.
We're going to dive into that today on the show.
That's a great question, and it's something that researchers have actually been looking into quite a bit.
Okay.
And it turns out that this seemingly, simple behavior
Yeah.
of kids just noticing numbers kind of randomly like that might actually tell us something pretty important
Really?
about how they learn math.
Interesting.
Yeah, so you're talking about something called spontaneous focusing on numerosity, or SFON for
I saw
short.
SFON.
Yeah.
Yeah, and there's this really fascinating meta-analysis
Hmm.
that was just published in the Educational Psychology Review in March of 2025
Okay.
called The Relation Between Spontaneous Focusing on Numerosity and Mathematics Performance. A meta-analysis.
I'm guessing a meta-analysis means they looked at a bunch of different studies all at once. That's exactly what a meta-analysis is. It's like a study of studies
Okay.
where researchers pull together data from lots of different individual research projects to get a bigger picture of what's going on.
Gotcha. So how many studies did they look at in this one?
This particular meta-analysis combined the findings from 29 different studies.
Wow.
And we're talking about data from over 6,600 children.
That's a lot of kids.
That's a huge sample size,
Yeah.
which makes the findings all the more compelling. So our goal in this deep dive is to really understand
Okay.
what this really comprehensive view tells us about the connection between a child's inherent interest in numbers and how they do in math. What are the key takeaways?
So I'm guessing the big finding is that kids who notice numbers everywhere are good at math.
You're on the right track. The researchers did find a significant positive correlation between SFON and math performance.
Okay, so what does that mean in real life? Like, can we spot these kids who are going to be math whizzes just by seeing how much they like to count things?
Well, it's not quite that simple, but the connection is definitely there. So the researchers found a correlation of R equals 0.274.
Hmm.
Now, I know that might sound a bit technical,
Yes.
but basically it means that on average, a child who frequently, comments on how many things there are or
Mhm.
points out the numerical features of their surroundings is more likely to do well in various math tasks.
So it's not a guarantee, but it's a pretty good indicator.
Exactly. It's one piece of the puzzle. And what makes it even more intriguing is that this connection seems to work both ways.
Oh, interesting. So it's not just that being good at math makes you notice numbers more. It's like the interest in numbers itself might actually help kids get better at math.
That's the really fascinating part. It suggests that this kind of natural curiosity about quantity and number could be laying an early foundation for understanding those more formal mathematical concepts.
So they're already kind of thinking mathematically even before they're learning like formulas and equations?
Right. And then as their math skills develop, they might become even more attuned to numbers around them. So it's like a positive feedback loop.
Gotcha. So the more they notice numbers, the better they get at math, and the better they get at math, the more they notice numbers.
Precisely. And what's really important to remember here is that the researchers were very careful to account for other cognitive skills in their analysis.
Oh, okay. Like what kind of skills?
Things like working memory, nonverbal reasoning, their ability to think logically and solve problems without words,
Right.
and their ability to focus and control their impulses, what we call inhibition.
So they wanted to make sure it wasn't just that smarter kids in general were both good at math and noticed numbers more.
Exactly. They wanted to isolate the specific role of SFON, and what they found is that the link between SFON and math held strong, even when they took those other cognitive factors into account.
So it's not just a byproduct of being smart overall.
Yeah.
It seems like SFON has its own unique contribution to make when it comes to learning math.
Precisely. That's a crucial point.
Okay, so we've got this link between SFON and math skills, but the study also mentioned that how researchers measure SFON can make a difference.
Oh, absolutely. That's a really important detail.
Okay, so how do they measure something like that?
Well, there are a couple of different approaches. Some studies might rely on questionnaires or surveys, where they ask parents or teachers about a child's tendency to focus on numbers.
Okay, so like, does your child often count things without being asked, that kind of thing?
Exactly. But other studies use something called behavioral tasks.
Interesting. What's a behavioral task?
So in a behavioral task, you actually observe the child directly
Yeah.
in specific situations. For example, You might have a child playing with a set of blocks,
Okay.
and you'd carefully watch to see if they spontaneously comment on the number of blocks they have, or if they start grouping them by number,
I see.
without any prompting from the researcher.
So it's about seeing how they naturally interact with numbers in their environment.
Exactly. And what's really interesting is that the meta-analysis found that these behavioral tasks were actually better at predicting math performance.
Oh, so they were a stronger indicator than the questionnaires.
Yes. And it makes sense when you think about it. Seeing a child actively do something with numbers in a spontaneous way
Yeah.
probably gives you a more accurate picture of their true inclination than just asking someone else about it.
Right. It's like the difference between saying you like to cook and actually whipping up a gourmet meal.
That's a great analogy.
But it wasn't just about if they noticed the numbers, it was also about how they noticed them, right?
You're picking up on another key finding. The scoring methods used in these studies actually mattered a lot.
In what way?
So the studies that looked at both the accuracy of a child's numerical judgments and whether or not they actually said a number, whether they quantified what they were seeing, showed a stronger relationship with math skills.
So it's one thing to notice that there are some cars over there,
Right.
but it's another thing to say, hey, look, there are 4 cars.
Exactly. It's that active step of attaching a specific number to what they're seeing.
Okay.
That seems to be really important.
So it's not just about having an eye for numbers. It's about actually engaging with them on a more quantitative level.
Precisely.
Now, what about the size of the numbers involved? Does that make a difference?
That's another great question. And the meta-analysis actually found that SFON tasks involving smaller numbers, less than 10, showed a stronger connection to overall math performance.
Oh, that's interesting. So is it because those smaller numbers are like the building blocks of math?
That's very likely the case. Think about it. Our earliest understanding of numbers really comes from those small sets.
Yeah.
Learning to count on our fingers, recognizing small groups of objects, that kind of thing.
Right.
So a child's spontaneous attention to those really fundamental numerical units, those small quantities,
Yeah.
could be a strong indicator of how well they'll grasp those early mathematical concepts.
Like you learn to count to 5 before you learn to count to 20.
Exactly. It's all about building those foundations.
Okay, so that makes sense. What about the way this relationship plays out over time? Like, does early SFON predict later math skills, or is it the other way around?
That's where things get a bit more nuanced.
Okay.
The study actually suggests that the longitudinal link from math performance to later SFON might actually be stronger.
So that means that being good at math early on might actually make kids notice numbers more later on.
That's one way to interpret the findings. It might seem a bit counterintuitive,
Yeah.
but think about it this way. As children develop a stronger grasp of mathematical concepts, and they start to experience success in math,
Right.
they might actually become more attuned to those numerical aspects of the world around them.
So it's like math skills kind of open their eyes to the numbers that were always there.
That's a great way to put it. Competence can breed interest and awareness.
Gotcha. So even though that initial spark of spontaneous numerical focus can be really helpful early on, later on, those math skills they've built might actually make that numerical awareness even stronger.
That's the idea. It's a really cool interplay between those two things.
Yeah, like a back and forth kind of thing.
Exactly. And it highlights just how dynamic the learning process really is.
So does age play a role in all of this?
Absolutely. Age is another crucial factor.
How so?
Well, the meta-analysis indicated that the link between SFON and math performance actually gets stronger as children get older.
So the older they get, the more important this spontaneous number focus becomes.
That's what the data suggests. And one possible explanation is that as mathematical concepts become more abstract and complex,
Right.
having that really strong fundamental sense of number and quantity becomes even more important.
So those who are really good at noticing and understanding numbers from an early age might have a real advantage when they start tackling those more challenging math concepts later on.
Exactly.
Yeah.
It's like their early SFON laid the groundwork for that deeper understanding.
Now, I know we've talked about a lot of different factors here, how SFON has measured the size, the numbers, time, age, all that stuff.
Yeah.
But I'm guessing these things don't all operate in isolation.
Yeah, you are absolutely right. The researchers actually found evidence of interaction effects.
What does that mean?
It means that these different factors can influence each other in complex ways.
Okay, so give me an example.
Sure. So the way a child's SFON is measured might actually be more or less predictive of their math abilities, depending on their age or the specific types of math tasks they're doing.
Gotcha. So it's not like a one-size-fits-all kind of situation.
Precisely. It just highlights how intricate this relationship really is, and it suggests that future research needs to take all of these different factors into account together.
That makes sense. This is a pretty complex interplay of different elements.
Yeah, it's definitely not a simple, straightforward connection, but that's what makes it so fascinating to study.
Right. Human development is rarely simple and straightforward.
Exactly. There's always more to uncover.
Okay, so after diving deep into all of this research,
Yeah.
what's the key takeaway for our listeners today?
Well, I think the main message is that a child's natural inclination to notice and engage with numbers,
Mm.
what we've been calling spontaneous, focusing on numerosity or SFON,
Right.
has a really significant and multifaceted relationship with their mathematical development.
It's not just about seeing numbers. It's about really thinking about them in a quantitative way.
Exactly. And how we observe and measure this tendency, the specific numbers involved the child's age, all of these things play a role in this intricate connection.
So for parents and educators out there, it sounds like nurturing that early natural curiosity about numbers could really make a difference in a child's math journey.
Absolutely. And this meta-analysis provides a lot of really strong evidence to support that idea.
This has been a really fascinating look at something that we see all the time, but might not always stop to think about.
Yeah, it's easy to overlook those everyday moments.
It makes you wonder about all those times you see a kid pointing out numbers or counting things seemingly out of the blue. So for our listeners out there, here's something to ponder. Given these findings, what are some practical ways we can encourage and support a child's spontaneous interest in numbers in their daily lives? And how might that intentional nurturing of that natural curiosity have a lasting impact on their confidence and competence in math? It's definitely worth exploring.
I think that's a great question for everyone to consider.